Bayes' theorem tells us the probability of an event given knowledge that a previously related event happened earlier. Let's look at an example to explain this more clearly. Let's say we have two dices. One of the dice is a fair six-sided dice as normal. The second dice is biased to land on 6 50% of the time. The question is, what is the probability we roll a 6 using the biased dice? We understand from this question two events happening. We first pick a dice and then we roll it and get a 6. Those are our two events in the question. To answer this question, we will need our Bayes' theorem formula. This formula reads out the probability of A happening given that B has already happened, which is equal to the probability of B given that A has happened, times the probability of A divided by the probability of B. This is our formula, and the question is to find the probability we rolled the biased dice and got a 6. So can you now see how this formula sounds similar to our question? We can say that event A is that we picked up the biased dice and event B is that we rolled a 6. We also need to know the probability of B happening given that A has already happened. This is written as the probability we get a 6 given that we rolled a biased dice. Next, we need to know the probability of A, which is the biased dice, and the probability of B, which is to roll a 6. Now that we've listed all we need for our formula, it can be a lot more straightforward to plug in the values. So what are the values for these probabilities? The first one is the question that we are really trying to answer. The second one states the probability of rolling a 6 given that we roll the biased dice. We can simply say this equals to 1/2, because the question itself tells us that the dice is biased to land on 6 50% of the time. Next, let's look at the probability of A. The probability of A is the chance we pick a biased die or the fair dice. Since there are only two options, this would also equal to 1/2 because there's only two dice that we can pick. Now we need to work out the probability of B, also the probability of rolling a 6. Remember, there are two events that happen in this scenario. First, let's say we pick the biased dice and then roll a 6. On the other hand, we pick a fair dice and roll a 6. The chance of us picking a biased dice is 1/2, and then rolling a 6 would also be 1/2. Picking a fair dice would be 1/2, but then rolling a 6 would be 1/6, because this time it's a fair dice. Each side has an equal chance. We now must multiply our two fractions with or without a calculator, which is entirely up to you. We get 1/4 multiplied by 1/12. To get a common denominator, multiply by 3, which gives us 3/12 times by 1/12, which is equal to 4/12. And 4/12 is equal to 1/3. So 1/3 is our answer for the probability of B. The probability of rolling a 6 is 1/3. So now that we have all our values, we can return to answering the main question. The probability of rolling the biased dice, given that we got a 6. So we can write the probability of 1/2, which is probability of B, given that A has happened, multiplied by the probability of A, which is 1/2, then divided by the probability of B, which is 1/3. That calculates to 1/4 over 1/3 to find our answer. To use multiplication, we can flip the denominator and calculate it more simply this way. This gives our final answer 3/4. So the probability of rolling one dice, supposedly the biased dice, and getting a 6 is 3/4. And that is our final answer.